Welcome to screencast number 3 for Unit 8, Lesson 4, and I am on, I think it's page 475, yes. All right, we're looking at surface weather maps, and we're going to spend a few minutes looking at those and talking about them. All right, on a surface weather map, typically air pressures are shown, the location of cold fronts and warm fronts are also shown. Depending on who's making the map, you might also see precipitation, rain or sleet or snow, hail. Okay. How do we show air pressure on a weather map? Well, we show air pressure by using something called isobars. Isobars are lines that connect points of equal air pressure and are marked in units called millibars. We talked about that a little bit. Millibars is just a unit of pressure. Isobars form closed loops. Isobars connect areas of equal pressure in much the same way that contour lines on a topographic map connected areas that had the same elevation. Okay. All right, so the isobars are drawn on the map. You can see that at the bottom on the illustration of the weather map that they give you. Okay. So isobars form closed loops, and the center of these loops is marked with either a capital H for a high pressure area or an L for a low pressure area. Okay, we usually show fronts also on surface weather maps. We use blue lines with little blue triangles for cold fronts. We use red lines with red half circles for warm fronts. Stationary fronts look like a combination of the two. You have a little piece of cold front, a little piece of warm front. Okay, let me explain a little bit about cold fronts and warm fronts. All right, a cold front is going to look like this, and it's a boundary line. Okay, a front is just a boundary separating two air masses. Okay, it's called a cold front because it's the colder air that is advancing or moving and pushing the warmer air out of the way. So for instance, if you saw this on a weather map, it means that the cold front is moving this way, because you can kind of think of this as a tip of an arrow showing you the direction. So the cold front is moving this way. So the colder air is on this side of the boundary, okay, and is moving this way and replacing warmer air, which is down here. Okay. A warm front looks like this. Okay. It can be turned around, whatever. But the little half circles, you can kind of think of them as similar to these arrows. Okay. It's the sort of the head of the arrow, and it indicates that the warm front is headed this direction. Okay. Because it's a warm front, it's the warmer air that is moving in and advancing. So this would be warm air moving this direction and replacing a mass of colder air. Okay. All right, well, what if you have colder air, for instance, here, warmer air down here, and neither one of them is moving? Okay, that would be a stationary front. So you still have a boundary between two different air masses. This one down here is warmer. This one up here is cooler, but neither one of them are moving, so we call that a stationary front. Okay, stationary because it's not moving. Okay, then we have an occluded front. Basically, when a cold front catches up with a warm front, okay, this is what you get. It's an occluded front. It's kind of like a cold front runs over a warm front sort of thing. Okay, we won't see this one too much, but just wanted to point that one out. Okay. Okay, so there are a couple of notes that I want you to make. Of course, I typed it in because I'm using the online student edition to do this screencast. But anyway, you can write this out to the side over here. Okay. Isobars connect locations with the same pressure in the same way that contour lines connect locations with the same elevation. Okay, so add that over here out to the side. And with your fronts, I added a note, again, just make room for it out to the side somewhere. On cold fronts, think of the blue triangles as the tips of arrows that point to where the front is headed, and the semicircles on the warm fronts do the same thing. It points to where they're headed. Okay, let's scroll down a little bit and look at the weather map that they give us. All right. There is a key right here. Not all of the weather maps that you're going to be given have as detailed a key, but here we go. All right, the light green indicates light rain, dark green indicates heavy rain, pink is rain, ice, and snow mixed, white is snow. The white lines are isobars, and remember that an isobar connects areas that have the same air pressure. H's indicate a high pressure center, L's indicate a low pressure center, cold fronts, warm fronts, stationary fronts, and occluded fronts. Okay. All right. For your highs and lows, I'm going to make a note that I would like you guys to write down. All right, so I've added another note that I would like you to write down somewhere in the margin, that generally you need to understand that high pressure areas are associated with clear skies and pretty weather. Low pressure areas are more often linked to cloudy weather and precipitation. And you can probably see what I'm talking about on the map that's down here. Okay. You have a high pressure area right here located over Alabama, and there's no precipitation anywhere around it. It's probably clear skies, nice weather. Here's a low pressure area, and right over here close with it is precipitation. Here's another low pressure area, and again you have precipitation close by. Low, and you have some precipitation. All right. All right, well, let's look at the map carefully and attempt to answer the questions. All right, on 17 it says, what type of front has recently passed through this area? Well, I can look at this line and I can look at the arrows on the cold front, and I know that the cold front is headed this way. So that tells me that it's already been through this area. So 17, what type of front has recently passed through this area? And it's a cold front. Down here, what are the white lines on the map? Again, go over here. They are isobars. They are lines that connect areas of the same pressure. Okay, this is a forecast map from the National Weather Service for Wednesday, April the 20th, 2016. And there's a lot of information. It's kind of jumbled up. This is not the kind of map that they show the general public because it's a little bit too complicated, I guess. Anyway, but there are lines shown sort of in maroon. These are isobars. Okay, they are lines that connect areas of equal pressure. You notice that the numbers on the lines are getting smaller and smaller and smaller as you go into this low pressure area. As you leave the low pressure area, cross the isobars, and head to the high pressure area, the numbers on the lines get bigger and bigger and bigger because this is a high pressure area. You're going to have high pressures, low pressure area. Okay, so the numbers on those lines are isobar readings. Okay, here we have another area of low pressure, low pressure. We have a high pressure area in here, low pressure right there. Anyway, this one's probably the nicest example. Okay, you just have circle after circle after circle of isobars connecting areas of the same pressure. All right, we also have a couple of fronts that we can look at right here. is a warm front. So in here is warm air headed this way. Here is a cold front. So this air back in here is colder than this air in here, and this mass of colder air is moving this direction. Well, behind it is a mass of even colder air moving this direction. Okay, so cold front, right along here, cold front, but we've also got low pressure areas. Let's look down here in Texas. This part right here is a stationary front, and then this part in here is a cold front, meaning that this air over here is colder than this air down here, and the colder air is moving this direction, and then it winds up being a stationary front for this little bit. Okay, and then cold front again. All right, what on earth is this? Well, let's go look at our legend and find out. Scroll down. Here it is, right here. This is a squall line. It's a line of active thunderstorms, either continuous or with breaks. Okay, it's a line of active thunderstorms. Let me show you the radar that's going on right now, where this squall line is indicated. Oops, that's not. Let's see. Nope. Here we go. Okay, so we have a squall line right here. Let me pull up the radar and I'll show you what's happening, because this is a couple of hours old, but it's fairly recent. Okay, so this is our National Weather Service weather.gov site, and I'm going to come over here and go to radar, and you see that squall line is going to be right along this area, that boundary, right along that edge of those thunderstorms. Okay, because you've got a cold front back here, and this squall line, this area of active thunderstorms, is right there. Okay, so it looks like that let's see, we've got Southern Plains, that's who we are. Okay, we're down here. It's likely that we're going to have some thunderstorms later on in the morning. Okay. All right, down at the bottom of the page, it talks a little bit about upper air charts. I think I mentioned in the last screencast that it was important not only for us to gather information at the ground level, but that we also needed to gather information further up in the atmosphere. Okay, and there's several reasons for this. Okay. Once you gather the information, the weather map that you make about what's going on higher in the atmosphere is called an upper air chart. Okay, upper air charts are important because they show wind and air pressure at the middle and upper levels of the Earth's atmosphere, and this information from upper air charts indicates if and where weather systems are going to form, if these systems will move, where they're probably going to move to. Are they going to remain stationary? Are they going to gather strength, fall apart, things like that? So it's important for us to not only know what's going on at the surface of the Earth, but what's going on higher up in the atmosphere can help us make predictions about what the weather is going to do. Okay.